First equal 1202. Smallest string with swaps. And for this question, it gives us a string in a list of lists, which is called pairs. So it says that, for example, the pairs that is look like this. Everyone, it is every element which is size to one-dimensional array, and that is a pair, right? 0 and 3, and 1 and 2, that is pair. That is that for any pair you can swap any times, and let's try to find the smallest lexicographical string. So let's look at the second example. You see 0, 1, 2, 3. They can swap, and 1 and 2 can swap. 1, 2, and 0 and 2 can swap. So that means all of this, and this, they can swap, right? So that means for every, we can look at the pairs to see which index they connect to each other. For example, we have 0 connect to 3, 3 connect to 0 connect to 2, right? And also 1 connect to 2. That means the orders of 0 or 0, 1, 2, 3, we can just have a lexicographical sorting for this kind of indexes. So that means this kind of index we can consider just like a one set, right? So what we're thinking about is that for this string, it have n numbers. We can consider to use the pairs, trying to see how many sets we are going to have. For example, if we have 1, 3, 6, for example, 7, right? If this one is a set, is belong to the same set, they are connected, then we just sort every element in this 1, 2, 1, 3, 6, 7. And if we have some other element, for example, 2, 5, 8, right? If these 3 are connected, we just sort these 3, right? So in the end, the smallest will be the sorted value for each set. We compose a string based on the sorted one, right? Sorted sets. So what we're thinking about that is we need to find how many indexes they are connected. In this case, the intuitive way we're thinking about is use union find. So what we're thinking about is that we can we can have just find for example, every collection is for example 1, 3, 6, 7, right? And for this one, we need to reorder its sequence. For example, this is if 1, 3, 6, 7. If, for example, this is the F, this is A, and if this is, for example, B and G, right? What we want is that for the first position, we should have A, B, F, G, right? So we should sort by this chart by lexicographic, and we reorder it. Yeah. So what we're thinking about that is that we convert this one as an char array, right? And we can have for the union find we can have a list of index, and another we can have create two index. One is the index, another is the array. We have a copy with it, which we sort this by the number, right, from small list to largest, and then the second list we sort by the char, use a lexicographical order, and then we just rearrange. So let's begin to write code for this. I'm going. So for we know every if this string have length n, we can for every character we can use an index to represent its character. So we can have use an write the class unified, and we'll have further, and we're going to have a public unified int a, right? So I have the public equals new int, and we have for int I equals 0, and smaller than I plus plus, and we have the I equals and we just write two functions. One is union, right? In union in A in B, but it is how in FA equals A with the find and in FA B and B. So I say for FA must got a dynamic with FA stop it, and what we do is that the father of A underscore A equals A underscore B, right? And the find function is being defined in X. So I say if X equals FA other X, right? So that we'll just return X. Then we'll have father X find and that we have to return the X. So we have this one as a help function, and we are going to have change this one to the char array plus s to char array. And we are going to have an array dot length, and we have a unified function to actually put new unified thing. So the first thing is that we need to do the union, and so that is for list integer for pair in pairs, right? We have UF of union pair get pair and pair get wrong, right? Now second thing is we will get the index set. Okay. what we are going to use a map. Method. The key will be the parent, the top parent, or the which we will find the find that is the top parent of the set, and we are going to store every connected index to this list. Now we close the new hash map. Then what we need is that we need to compose a map, right, for int I equals 0, not smaller than I plus plus map compute that sense. So we'll have UF find this I as a key, and we'll have lambda expression new array list and add I. So in this case, the map size will be the how many connected components or connected sets. So for every list in this map values, right, that is one connect set, we need to reorder that. So I have for list integer list map of values. We need to reorder this, and based on this array, right? So we need a sort. This is the index, and have another array. For example, we can have a copy of this list integer copy list because new array list. So we are going to sort the list by index. So this is because do we need yeah, we need to have a copy of this because we need to sort this by the character lexical order. And when we put to this list, this is the it may not guarantee the order, but it says that pair is always smallest. And so we sort this and sort this by the number and sort this by the chart. So we'll have collections dot list, and we'll have collections dot copy list. We are sort by its lexical. Lexical will be the thing is that we are going to change the order in this array. So what about we have a dictionary first as each array again. I have another copy, right? So we'll just have integer compare. We'll have AB, AB is char is also a one can convert to integer, right? So we'll have integer compare array A, array B, right? So in this case, these index are thought in lexical order. So what we do is that we just have for int I equals 0, that's smaller than list bucket size I plus. Just reorder this array list if I equals array. We are using the copy because the order changed. Dictionary copy list if in the end, we just return new array and we reorder it. Yes. Okay, so let's look at the time complexity. If the length is n, right? We will iterate. The first thing is that it will have pair size, right? So this pair, we have a union, but the pair is O length. For example, there are length pairs that is O length. Then we iterate the string length. For example, this is L, right? That we also have the OL operation, and this is O pair length operation, and for this one, that is for every set, we do a reorder, right? Reorder that is n log this size. So we'll see for the length, right? There is a float, right? So it will this one will averagely be the string length log string length. So the final time complexity will be compared. This is O pair length, and this is O string length log length. So we'll compare the bigger one.